Good morning, all of you. ඇත්තටම මම මුලින්ම apologize කරන්න ඕනේ මට මේ class 2 එක එදා record කරන්න බැරි වුණා. ඒකත් එක්ක පස්සේ record කරන්න කීප පාරක් try කරත් continue කරන්න බැරි වුණා තිබ්බ ප්‍රශ්නත් එක්ක. ඒක නිසා පොඩ්ඩක් මේක late වුණා class 2 එක upload කරන්න English medium කට්ටියගේ. ඒක නිසා මුලින්ම මම apologize කරන්න ඕනේ විශේෂයෙන් recording වලින් විතරක් live class එක නතෝ recording වලින් විතරක් බලන දරුවෝ ඉන්නවා. ඒ නිසා මම මුලින්ම apologize කරන්න ඕනේ ඒගොල්ලන්ගේ. ඒගොල්ලන්ටත් කිසිදු වෙනසක් සිදු නොවන විදිහට අර note එකම ඒ දරුවන්ගේ note එකම ආය පාරක් ඒ විදිහටම කරන්න මම මේ try කරනවා. හරි. ඒ note එකම තමයි දෙන්න පුතේ වෙනසක් කරන්න නැහැ ඕගොල්ලන්ට. ඒ නිසා ඒ note එකම ඒ විදිහටම ඕගොල්ලන්ටම ලබා දෙනවා. හරි. හොඳයි. එහෙනම් අපි start කරමු අපේ lesson එක. Okay. In our first class, we have discussed about physical quantities, and we have categorized those physical quantities into three main groups. What are those? First one is fundamental physical quantities. Second thing, derived physical quantities, Putha. Physical quantities. And third one, supplementary physical quantities. Fundamental physical quantities, derived physical quantities, and supplementary physical quantities. Okay. In this case, those physical quantities are categorized according to the way of measurement. Initially, we have defined a physical quantity as a property that can be measured. Is called as a physical quantity. So there are two ways of measuring the physical quantity. Some physical quantities can be measured directly. As example, length, mass, time. Those kind of physical quantities can be measured directly. But some properties can be measured indirectly. Indirectly means using directly measured physical quantities, such as area. We can measure area, but the thing is, if you want to measure area, we have to measure two lengths first, and after that we have to do some calculation and get the value of area. Okay, so we cannot measure area directly, but we can measure. So it is a measurable property. It is a measurable property. So area is a physical quantity. Because it is a measurable property, but it cannot be measured directly. We have to use directly measured properties to derive that physical quantity. So those kind of physical quantities have to be derived. Okay, have to be derived. So these kind of physical quantities are called as derived physical quantities. Because we have to use fundamental physical quantities to derive them. As an example, we can say speed. Speed means distance over time. Distance is distance is a length, time is time. So we can measure the distance and time directly. Then we can derive speed. Okay, speed, then acceleration, force, area, volume, density. Those kind of physical quantities cannot be measured directly, but those are measurable properties. So those are physical quantities but cannot be measured directly. Those kind of physical quantities are called as derived physical quantities. The properties that can be measured directly are called as fundamental physical quantities. In that case, we have found 7 fundamental physical quantities. 7 fundamental physical quantities. That means those physical quantities can be measured directly. Okay. Then, supplementary physical quantities. What are those? Those are angles. Angles with plane angle and solid angle. Those are angles. Actually, angles can be measured directly. It can be measured directly. You can use actually you can measure angles, no? It can be measured directly. But the thing is the definition of the angle. According to the definition of angle, angle C is equal to length over length. According to S equal R theta, theta is S over R puta. S over R. S means the arc length, it is a length. R is the radius, it also a length. So theta is length over length. Length over length means it should not have a unit, because length is measured by the length that is in the numerator is measured by meter or something. Then the radius, it is also a length, so it should be measured by meter too. So meter to meter will be cancelled out. So theta should not have a unit, but we have to adapt a unit to measure angle. Okay, so there is a contradiction. Due to that contradiction, angles are not categorized under fundamental physical quantities. So angles are categorized into separate category. It is called as supplementary physical quantity. Supplementary physical quantity. So those are the things that we discuss in our class 1. This is the first type of categorization of physical quantities. Okay. Then other thing is, this categorization is based on the way of measuring that physical quantity. Now, the second thing, the second categorization is based on the properties of physical quantities. Properties of physical quantity. Okay. Okay. Let's look some examples. Okay. Okay. Suppose we are given some physical quantities, velocity, speed, then refractive index, suppose we are given this kind of physical quantity. Okay, so if we take velocity, that physical quantity, I think you know this one in your all else, that physical quantity is a vector. It's a vector. If it is a vector, that physical quantity should have a magnitude and direction and unit. Okay. So those are the 3 properties we are going to consider in this categorization. Okay. Normally, according to the definition of physical quantities are the properties that can be measured. So if they can measure, if they can be measured, that means all the physical quantities should have a magnitude. Otherwise, it cannot be measured. No. If it can be measured, that means the physical quantity should have a magnitude. The measured value, that measured value is the magnitude of that physical quantity. So every physical quantity should have a magnitude. Should have a magnitude, Putta. Okay. In addition to that property, now we are going to consider another two properties. What are those? The direction and the unit. The direction and the unit. Because direction and units are not characteristic of all physical quantities. Okay. Okay. Such as this example. If we consider velocity, the velocity has a magnitude. As this is a physical quantity, it has a magnitude. It has a magnitude, Putta. And it also has a direction. Direction and a unit. Direction and a unit. So velocity has all three properties: magnitude, direction, and unit. Magnitude, direction, and unit. Such physical quantities are called as vectors. Vectors. If any physical quantity has a magnitude and a direction and also a unit, those kind of physical quantities are called as vectors. So if we consider speed, speed or mass or speed or time, they don't have a direction. Time doesn't have a direction, no. Mass doesn't have a direction, no. Speed is the scale part of velocity. So speed doesn't have a direction. So this physical quantity doesn't have a direction, but it has magnitude and a unit. It has magnitude and a unit. It has magnitude and a unit. Okay. So this kind of physical quantities have all three properties, but this kind of physical quantities have only two properties, that are magnitude and units. Those are not having a direction. Then you know what refractive index? I think you have done this one in your orders. Refractive index. Refractive index is just a number, no? It's just a number. So some physical quantities like refractive index, they just have a value only. That means magnitude only, Putta. So refractive index does not have a unit and also a direction. Okay. So this kind of physical quantities have only a magnitude. So if we consider these three properties, these three properties, magnitude is a common property for all scale or all physical quantities, but direction and unit are not a common property. So according to having these special characteristics, we can categorize physical quantities into three main groups. That is the second method of categorization of physical quantity. So we can categorize physical quantities into three main groups according to their properties. What are those properties? magnitude, direction, and unit. Okay. Okay. Now we have to write the note. I will give the same note in our previous class. Okay. Okay. Write this one. We can classify. We can classify. We can classify physical quantities. We can classify physical quantities according to their properties. According to their properties. According to their properties. Every physical quantity has a magnitude. Has a magnitude. In addition to that, some physical quantities also have a direction and a unit. Direction and a unit. Some physical quantities also have a direction and a unit. According to those properties, physical quantities, sorry, physical quantities can be categorized into three main groups. Can be categorized into three main groups. Okay, we are write them. Okay. Physical quantities in direction. Second thing, magnitude. Third one, unit. Physical quantities having one, magnitude and unit. Magnitude and unit. Third category is physical quantities having magnitude only. Magnitude only. Okay. These are called as vectors. Vectors. Okay. The specialty in vectors is they have a directions. They have directions. They have directions. But these two physical quantities do not have directions. So those are called as scalar quantity. Scalar quantities. Both of them are called as scalar quantities. Scalar quantities. Okay. Example for vectors. Displacement. Displacement. Velocity. Force. Etc. Example for this type of physical quantities: mass, time, distance, speed, then example for this kind of physical quantity: refractive index, refractive index, strain. I will explain what this strain is. Then relative density, relative density, relative density. Those are examples for this type of physical quantities: refractive index, strain, relative density. An example for this type of physical quantities are mass, time, distance, speed. And example for vectors: displacement, velocity, force. You can note down this thing. Now you can note down this thing. Sorry. Okay. I think you can write this one. Then we can move to the next section. Okay. Our next session is units. It is a main topic, units. Units. Okay. Suppose you are given a rod. You are given a rod. And suppose it is AB. You are given a rod and asked to measure the length of this rod. Asked to measure the length of this rod. Okay. Then one student say, sir, it is 5. It is 5. Another student say, no, sir, it is not 5, it is 10. Another one said, no, sir, I got 7. Oh. Who is right? Who is right? Can I decide whether A or whether B or whether C is right? Can I decide? How can I determine who is right? I cannot do that, no, because first student says it is 5. The second student says no, it is 10. Other one said, third one said, no, sir, it is 7. But I cannot say who is right. No, because they are saying just a number, no? They said just a number. 5, 10, 7. They are just a number. No? So if it is just a number, how can I determine whether it is right or not? Right or not? Suppose if they measure the rod in meter rule, using meter rule, then if they use a meter ruler, suppose first student got 2 meter length, then the second student also get the same length, and the third student also get the same length. So what is the different thing? What is the difference in first case and second case? In first case, we have not defined the scale. We have not defined the scale that is used to measure this rod. But in the second case, we have specified a special scale to measure this rod. I think the second case is much meaningful, no? The first case is actually meaningless because we cannot determine whether the measured value is correct or not. We cannot double check. We cannot, actually it is meaningless, totally meaningless. But in the second case, if we use a scale, if we use a standard scale to measure a physical quantity, the value will be much meaningful one. Okay, much meaningful one. So normally some standard scales are used to measure physical quantities. Those scales are called as units. Okay. If you want to measure a physical quantity, definitely we should have a scale. That scale should be a standardized scale. Standardized scale. That means that scale cannot be change according to person, location to location, region to region. That cannot be changed. There should be a standardized scale. So if we use a standardized scale to measure a physical quantity, that will be much meaningful, and that can be used to using anywhere and any standard as a standard practice. Okay. Okay. That kind of standardized scales are called as units. Why I'm saying standardized scale? Standardized scale. I will give you another example. No, same scenario, but another example. Okay. Now, the first student say, okay, sir, if you want a scale, then I will use my fingertips. I will use my fingertips and ask other two students use their fingertips. Then he measure this length using his fingertips. What will happen? What will happen? Are the three scales are same or not? Most probably they won't be the same value, no? They won't be same value, no? Because that is scale that is used for measuring this rod is not a standard scale. This scale is varying from person to person. It depends on person. Okay. So if we want to use a scale, to measure a physical quantity, that is scale should not be changed according to person, or location to location, or region to region, country to country. That cannot be changed, Puta. So that should be standard scale. So if it is a unit, that should be a standard scale. Relative to that scale, we can measure the measurements or value of a particular physical quantity. Okay. Okay. Right. The main topic, units. Measurement of physical quantities. The measurements of physical quantities must be made relative to a standardized scale. That scale is called as a unit. Of that physical quantity. Okay. Actually, in ancient times, the world wasn't globalized, so there was some standard scale location, country to country, the standardized scales were changed, were different. Okay, that's mean the countries like Britain, then France, and some European countries were using some another some standard scale, but they were not using that scales were not used by some some Asian countries. Asian countries had another scale system, another unit system, but in European countries had another unit system. So the unit systems used in ancient times are different from region to region. Okay. So there were some standardized scale with respect to or relative to some region. Okay. But the thing is, once the after the globalization of world, then actually there is a requirement to have one standardized scale. That's mean one standardized unit system for entire world. Because once the world is globalized, once the world is globalized, then the commercial purposes, the scientific purposes, actually we have to deal with all the countries with those kind of purposes. Therefore, there is a requirement of standard unit system for entire world. Okay. Therefore, after some time, the previous unit systems actually now we are not using those kind of different unit systems. After some time, the scientists have introduced a standardized scale that is called as SI unit system. SI unit system. Before the SI unit system, there were some different kind of unit systems depending on region to region. Okay. Okay. Shall we look some unit system that were used in ancient time? Okay. First thing is FPS system. FPS system. What is that? Normally, there were 7 fundamental physical quantities in our categorization. Among that 7 fundamental physical quantities, length, mass, and time are the main 3 fundamental physical quantities, because those 3 physical quantities are the physical quantities that are used to form derived physical quantities in most cases. Okay. Therefore, those 3 physical quantities are considered as the 3 main physical quantities among the fundamental physical quantities. So normally a unit system is called represented by the units of these 3 physical quantities. Normally a unit system is represented by the units of these 3 physical quantities. So F is the unit of length, P is the unit of mass, and S is the unit of time. F means the feet. F means feet. P means pounds. And S means seconds. So in FPS system, FPS system, feet feet was the feet was the unit of length, and pound was the unit of mass, and second was the unit of time. Okay. Okay. Actually, this system was introduced by France. Okay. FPS system. Okay. Then we can. Then there was another system that is called as CGS system. CGS system. CGS system. CGS system. In CGS system, the length is measured by centimeter, and mass is measured by grams, and time is measured by seconds. Okay. In CGS system, centimeter for length, grams for mass, and second for time. You can easily remember by the first letter of the unit. Okay. S for centimeter, G for gram, S for second, F for feet, P for pound, and S for second again. Then there was another system, another unit system that is MKS. MKS system. In the MKS system, meter was used to measure length. K means kilogram. Kilogram was used to measure mass, and seconds it was measure time. There were a lot of unit systems, but we are not going to learn each and every unit systems. We just need to get some informations. What were the examples for the unit systems that are used that were used in ancient time? Okay. Okay, write this one, Buddha. There were different kind of unit systems. There were different kind of unit systems. In various regions of the world. In various regions of the world. First one is FPS system. FPS system. Those are the examples, okay? Examples. You can write under the paragraph examples. FPS system. FPS system. This is feet, pounds, and seconds. Feet per. This is for length. Ah. Draw table. It is very easy. Example. System length as the first system is FPS. FPS system. In the system, F for feet, P for pounds, S for seconds. Then second one, CGS system. CGS system. Centimeter, gram, second. Centimeter, grams, see simple. Centimeter, grams, seconds. Third one, MK system. MK system. M for meter. Sorry, simple. Meter, kilograms, seconds. Meter, kilogram, seconds. Okay. Write down this table. Okay. Write down under this table. Therefore, the there were various units. Therefore, there were various units to measure the same physical quantity, from region to region. But as the world progressed, the activities carried out internationally increased. As the world progressed, the activities carried out internationally increase. Therefore, there was a requirement. There was a requirement of standard single unit system. Standard single unit system. Standard single unit system to measure physical quantities. So the currently use SI system. SI unit system was introduced to fulfill this requirement. Okay, Buddha. Then write a subtopic SI unit system. Okay, now we are going to discuss about SI unit system. Okay. As we discussed earlier, SI unit system is the internationally recognized unit system for measuring physical quantities. Okay. There are several physical unit systems and units to measure physical quantities, but SI system is the internationally recognized standard unit system for measuring physical quantities. Okay. Actually, I think you can remember we have classified physical quantities into 3 segments according to the way of measuring. What are those? Fundamental physical quantities, physical quantities, then supplementary physical quantities, and derived physical quantities. Derived physical quantities. Those are the three groups of physical quantities according to their way of measurements. Way of measurement. So according to this classification, we can classify SI units. SI units according to the classification of physical quantities. Accordingly, there are three kind of SI units. Those are fundamental SI units. Fundamental SI units are the units that are used to measure fundamental physical quantities. The units that are used to measure supplementary physical quantities are called as supplementary SI units. The SI unit that are used to measure derived physical quantities are called as derived SI units. So SI units also can be classified into three main segments according to the classification of physical quantities. So there are three types of SI units: fundamental or base units, supplementary units, and derived units. Okay. Okay, let's try it. Under this topic, write this one. SI unit system. SI unit system. SI unit system. Is the internationally recognized unit system. Is the internationally recognized unit system for measuring physical quantities. For measuring physical quantities. Okay, in a new paragraph. As we discussed earlier, physical quantities can be classified. Physical quantities can be classified into three main categories. According to the way of taking measurements. According to the way of taking measurements. accordingly, SI units can be classified into three main groups. Can be classified into three main groups. Okay. They write the next subtopic, that is fundamental or base SI units. That is the first category of SI units. Fundamental or base SI units. Don't write this table. First, write the topic. Fundamental or base SI units. Okay, under that topic, like this one, the SI units, units that are used to measure, fundamental physical quantities, are called as fundamental or base SI units. Are called as fundamental or base SI units. Okay. Okay. Now we can draw this table. Before draw this table, we have to explain it. Okay. Okay, Buddha. Those are the 7 fundamental physical quantities in physics. First one is length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Those are the 7 fundamental physical quantities. Okay. Okay. The SI unit The SI unit that is used to measure length is meter. Is meter. 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 The symbol of meter is simple M. Simple M. The symbol of meter is simple M. Then the SI unit that is used to measure mass is kilogram. All are simple. Kilogram. Kilogram. The symbol is K, simple K, simple G. There is no any space, okay? No space. Time. The SI unit is seconds. When you write the SI unit in words, the all letters should be simple letters. Simple letters. Seconds. Simple S. Okay, simple S. Seconds. Don't write capital S. Some students are writing capital S instead of simple S. Okay, that is wrong. The seconds means simple S. Temperature, Kelvin. Kelvin is a name of a scientist. Kelvin is a name of a scientist. So the symbol will be start from a capital letter. So this capital K. The electric current, ampere. 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 Ampere, okay. Ampere is also scientist Buddha. Therefore, the symbol is capital A. Capital A. The amount of substrate. Amount of substrate. Amount of substrate. It is measured by moles. M-O-L-E-S, moles. The symbol is M-O-L. Simple. Lola simple. M-O-L. Mole. Luminous intensity, candela. 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 The symbol is simple C, simple D. Simple C, simple D. Those are the SI units that are used to measure fundamental physical quantities. This table, you should remember this table. It is very clear-cut table. So you have to remember this table, okay? Okay. Draw the table. Okay. The second classification, the second category is supplementary physical SI units. Supplementary SI units. I will explain supplementary SI unit before derived SI units, okay? There are only two supplementary physical quantities. So there are only two supplementary SI units. What are the two kind of supplementary physical quantities? What are the two supplementary physical quantities, Puta? Angles. Angles are the supplementary physical quantities. So what are those? Plane angle and solid angle. Solid angle. Plane angle and solid angle. So the SI unit for plane angle, actually we have discussed that one, that is radian. 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 The symbol is RAD. Radian. Then there's a new SI unit for solid angle. It is called as steradian. 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 The symbol is simple S, simple R, simple S, simple R. Those are the two supplementary SI units. Okay. Then write the subtopic. Second one, supplementary SI units. Under that topic, draw this table. Okay. Our next topic is third category, that is derived SI unit. Derived SI units. Third one, derived SI unit. Okay. Derived SI units are used to measure derived physical quantities. Okay. When you are deriving a physical quantity, there is a definition, no? According to that definition, you have derived physical quantities, no? That means if you want to derive a physical quantity, definitely there should be a definition. According to that definition, there is an expression. That's the equation. Okay. You can use that expression or equation to derive the SI units too. Okay. Because in that expression, there are fundamental physical quantities that are used to derive the particular physical quantity. So we can assign the SI units of fundamental physical quantities in that expression. Then we can derive the derived SI units. Okay, as example, if you want to derive the SI units for velocity, first thing you have to do is you have to write the definition. You have to write the definition of velocity. Velocity is equal displacement over time. Displacement over time. In this case, you know a displacement is a length. So displacement is measured by meter and time is measured by second. Now you can assign those units to this expression. Assign those units for this expression. That means the upper part, the numerator is measured by meter, the denominator is measured by seconds. After that, you can simplify this one and take the SI units for velocity. So SI units for velocity is meter per second. Meter per second. You should leave a space here. You should leave a space because meter is a different physical quantity and time is another different physical quantity. Those are not same physical quantities. So if there are two different physical quantities, the units of them there should be a gap between the units of them. Okay. So don't write ms seconds without leaving a space. There should be a space. Meter per second. Then another example. This is example 1. Another example. Area. Area. If you want to find the SI units for area, then you have to write the definition of area. Area is length into length. Length into length. Length into length. No? Then those are the two basic or fundamental physical quantities that are used to derive area. Then you have to assign the SI units of them. If you assign the SI units of them, then definitely we will have the SI units of area. SI units of area. So the SI units of area, SI units of area is equal meter into meter. So meter is square. meter square. So that is the way of derived SI units. Derived SI units. First, you have to write the expression. You have to write the expression or definition of the SI derived SI unit. Then you should assign the SI units of basic physical quantities that are used to derive the particular physical quantity. Then you will have the SI unit of this particular physical quantity. So that is the way of derived SI units. Okay. Okay. Write it down. Derived SI units are used to measure derived physical quantities. Derived physical quantities. Derived physical quantities have relationships with fundamental physical quantities. Follow the following steps. The following steps are used to derive the SI units of derived physical quantities. Okay, the first step. Number one. Write the definition. Of the derived physical quantity as a equation. As an equation. Second one. Assign the SI units of SI units of fundamental physical quantities in that expression. Then you will have the SI units of the particular derived physical quantity. Write down these examples, okay? Example number 1, 2. We can write another example as a 3. Acceleration. Acceleration is equal velocity over time. Velocity is measured by sorry, ms minus 1, time is s, so this one is ms minus 2. Those are three examples. Write down them. First one, velocity. Second one, area. Third one, acceleration. Okay. You can pause the video and write down them. So I will continue the unit. Okay. Okay, Buddha. Look at this. Okay. According to our previous example, what is the SI unit of velocity? Velocity. What is the SI unit of velocity? M s minus 1 meter per second. Then what is the SI unit of acceleration? Acceleration. Meter per square second. MS minus 2. Okay. Okay. I think this one you have done in your orals. What is the SI unit of force? Force. What is the SI unit of force? If you want to measure force, what is the SI unit? It is Newton, no? It is Newton. It is Newton. If you want to derive force, if you want to derive that physical quantity, you have to use this expression F equal ma. That is the definition of force. No. If it is a definition, we can assign the SI units of these physical quantities to have the SI unit of force. The SI unit of mass is kilogram. When you are writing kilogram, don't leave a space. Kilogram is a single one. Okay, I will explain that one. Then ms minus 2. So according to this derivation, the SI unit of force should be kg ms minus 2. Look at this. There is no any space in kg. Kilogram is a one single unit. Then mass and s minus 2. There are two spaces because this m is for meter. Meter is a different physical quantity. This s for seconds. This is for seconds. That means time. Time is another physical quantity. So these three units are represented by three different physical quantities. Okay. If they are represented by three different physical quantities, then there should be a space between them. Okay. But this unit used for measure a single physical quantity, there should not be any space in their symbol. Okay. Okay. Like that. Okay. What is my argument is, so if I assign kilogram and ms minus 2 for this expression, the SI unit of unit of force should be kg ms minus 2. But we know the SI unit of force is Newton. Newton. Capital A. Capital A. What is the reason for this? What is the reason for this one? Actually, Newton is the scientist who investigate about forces, and he introduced so many investigations. So therefore, actually we use Newton instead of this SI unit. We use Newton instead of this SI unit. Actually, it is a honor for this scientist. Okay. Therefore, normally we use this Newton SI unit as the SI unit of force. So, if we want to measure derived physical quantity, there may be two kind of SI units. There may be two kind of SI units. Okay. There are some SI units. There are some SI units like Newton, Pascal, Hertz, Ampere. No, not Ampere. Not Ampere is basic physical quantity. SI units, no. But Newton, Pascal, Hertz, something like this kind of SI units. Actually, they have some special names. They have some special names. But look at these. Look at these SI units. They're just MS-1, MS-2. They don't have special names. Okay. Therefore, derived SI units can be categorized into two main segments. First one is SI units without a special name, and second one is SI unit with a special name. Okay. Then derived physical quantities can be categorized under two groups. Okay, write down it. SI units of derived physical quantities. SI units of derived physical quantities can be categorized under two main categories. The two main categories. First category. First category is derived SI units without a special name. Examples. Velocity. Velocity. This side it is m s minus 1. Second one, acceleration. M is minus 2. Third one, area. M is squared. Fourth one, volume. Meter squared. The meter cube. Fifth one, density. No. On the okay. Density. Kilogram per cubic meter. Sorry. First category. Write them down. Okay. Okay, you can pause the video and write them down. Okay. Second category. Second category is SI units with special names. With the special names. Okay, well, first one. Cos. That thing you know that. Cos. Normally, cos is measured by kg m s minus 2. Kg m s minus 2. But we have assigned Newton as its Newtons as its SI unit. This is Newtons. Second example. Pressure. Pressure is measured by force over area. Force means kg ms minus 2 over area means meter square. Force over area and pressure. So meter to 1 meter will be cancelled out. Then the unit should be kg m minus 1 s minus 2. That should be the SI unit. But we have assigned Pascal as its SI unit, Pascal. Capital P, simple A. Capital P, simple A. This is Pascal. Pascal. Third example. Power. Power means energy per second. Energy per second. Energy per second. Energy means kg meter square s minus 2. Energy per second. So kg m square s minus 3. Power means energy per second. Power means energy per second. Puta. I think you have done this in your always, no? If not, power means energy per second. Energy is measured by force into length. Force into length. Force means kg ms minus 2. Force means kg ms minus 2. So force into length means there should be another meter here. That means m squared. Kg m squared s minus 2. Because energy per second or work done in 1 second. Work done in 1 second. Both are same. Okay, work done and energy are same physical quantities. I think you can remember the work done. Work done is equal force into displacement. Force into displacement. No? Force into displacement. Force means kg ms minus 2 into displacement means meter. So you should multiply this by meter. If you multiply this by meter, this would be kg m squared s minus 2. The other thing, kg meter squared s minus 2. That is work done. Work done per second. You should divide it by seconds. So s will be brought to the numerator. If it is brought to numerator, then there will be minus 3. So this would be the unit. But the thing is, we have assigned another special name for this one. That is watt. That is watt. Capital W. Capital W. Okay, capital W. Capital W. That is watt. 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 Energy. Energy means equal work done. Work done means F into S. F into S. That's mean kg m squared s minus 2. So this would be the unit of SI unit of energy. But you know what is the special name that is used for measuring energy? What is that? Joule. Capital J. Capital J. Joule. Then fifth Another example, frequency. The definition of frequency is rotations per seconds, rotations per number of rotations per second, number of turns or number of especially number of turns per seconds. That means number for seconds, numbers for second. So SI units of SI unit of frequency would be per second, per second, per second. I will write that one. Frequency number of turns per unit time. Per unit time. Number of turns, number of terms, number of turns, number of turns per unit time. Okay, okay. I will write it again. Number of turns over time. Number of turns means it should be a number, no, Buddha? Number of turns means 2 turns, 3 turns, number of turns per second. Per second, how many turns are there? How many turns? Turns means we have to count them, no? We have to count them. So, in numerator, there should be a number here. Number. It is just a number. 2 or 3 or 4 or somewhat. Okay? It is just a number. So, number over time. Numbers do not have unit, no. So the numerator do not have a unit. It does the numerator doesn't have a unit. So the unit of frequency is 1 over second. 1 over second. 1 means this number does not have a unit. So this one can be written as 1 over s. So SI unit of this one should be per second, per second, per second, per second. But we have assigned hertz as its SI unit. Hertz, 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 hertz. Those are some examples for SI unit with special names. You had to note down this one. Okay. Shall we move to the next section? Okay. The next session. Prefix. Okay. Do not write anything. Okay. Suppose you are given a meter ruler. Now you are given a meter ruler and asked to measure the length of atomic radius. You are given a meter, right? Because atomic radius is a length. Atomic radius is a length, no? So the SI unit of length is meter. So you are given a meter ruler, putta. Now you are given a meter ruler because SI unit of length is meter. So the atomic radius is a meter length, no? So that should be measured by the SI unit. So you are given a meter ruler to measure atomic radius. Can you do that? Can you do that? No, that cannot be done. No, that cannot be done. What is the reason? The SI unit is much larger than the actual measurement. No, it is much larger than the actual measurement. We cannot measure atomic level measurement using a meter ruler. So we cannot get the masses. We cannot get the masses of atomic level electrons or proton using the balance. Using the balance, we cannot do that. Okay. Then suppose again you are given a meter ruler and you are asked to measure the distance from Earth to Jupiter. Earth to Jupiter. There's a spacecraft. Okay, don't worry about that. You are asked to measure the distance from Earth to Jupiter using a meter ruler. Can you do that again? No, you cannot. No, you cannot do that. Why? The actual measurement is too large than the SI unit. Then you should understand this one. There might be so many measurements that are too large and too small scales than the SI scale. In such cases, we cannot use SI scale to measure such kind of measurements because those are not practical. No, it is not practical. We cannot measure. Actually, some things are we cannot measure. We cannot measure atomic scale thing using meter ruler. We cannot measure that one. The Jupiter thing it may be measured, but the thing is, it is very difficult. No, so there may be some measurements that are out of range. Out of range means some measurements are too large with compare with the SI scale, and some measurements are too small compared with the SI scale. So how to measure that kind of measurement? How to measure that kind of measurement? In such cases, we have to convert SI scale into a larger scale or into a smaller scale to measure such kind of measurements. Okay. As example, if you want to measure the distance from Colombo to Mathura, you cannot use meter rule. Actually, it is very difficult. In such case, it is we can introduce kilometer scale than meter scale. No, if we measure using kilometer scale, it may be 200 or 300 kilo, 200 or nearly 200 kilometer from Colombo to Mathura. But if you meter scale, it may be 2 lakhs, no, 200,000 meters from Colombo to Mathura. Look at the difference. I think if there is a measurement, in larger scale or smaller scale, then we have to convert the SI scale to a suitable scale. We have to convert them. Okay. Okay. Suppose we have to measure some larger value, like a distance from Colombo to Mathura, from distance to Earth to Jupiter, some such kind of thing. Then you have to convert this SI scale into a larger scale, Musa. You have to convert the SI scale into a larger scale. If we want to convert the SI scale into a larger scale, then you should multiply the SI scale by a suitable value. As example, if you multiply meter scale by 1000, meter scale by 1000, you will have kilometer scale. If you multiply meter scale by 1000, you will have kilometer scale. Kilometer scale is a large scale compared to meter. If you want to convert SI scale into a large scale, you have to multiply this one. Multiply this one by a suitable number. If you want to convert the SI scale into a small scale, you have to divide the small scale by a suitable number. As an example, we can take this one. If you divide this one by 1000, you will have millimeter scale. You will have millimeter scale. That means if you want to convert the SI scale, you can multiply and divide the SI scale by a suitable number. Okay. Okay. Normally, that number is a power of 10. In this case, 10 to the power 3. Okay. In this case, 10 to the power minus 3. No? Division means multiplication of the reciprocal. No? So it will be minus 3. This is a plus 3. This is minus 3. Okay. So if we want to convert the SI unit into a larger scale or small scale, පුතා, you have to multiply this one by a suitable number. Okay, or divide it. That number, normally we assign a prefix. Normally we assign a name to that number. If you multiply this one by 1000, we assign that number as kilo. Kilo means you have to multiply SI unit by 1000, 10 to the power 3. Okay. If you want to divide the SI unit by 10 to the power 3, it would the division is represented by milli. If there is milli name, that means the SI unit is divided by 1000. Okay. Then there is a small letter. In front of the SI unit. To represent that number. This letter is called as the prefix, a prefix of this SI unit. Prefix. Okay. Prefix. So prefixes are represent the number that is used to convert the SI units into a larger unit or a smaller unit. Okay. Okay. In this case, if you want to multiply SI, if you want to convert the SI units into a larger scale, you have to multiply SI unit by a suitable number. So that numbers are called as multiples. Multiples, puta. Those numbers are called as multiples. Multiples. If you want to convert SI units into a small scale, you have to divide them. No, you have to divide them by a suitable number. So these kind of, actually this is a multiplication, or this is also a multiplication. No, so these kind of multiplication numbers are called as submultiples. Submultiples. So according to that, prefixes are divided into two categories. One is multiples, other one is submultiples. So if it is a multiple, that means we have to multiply the SI units and convert them into a larger scale. If it is a submultiple, that means we have to divide the SI unit and convert it into a small scale. Okay. Those are called as prefixes. I think you can understand. If not, please contact me. Okay. Write the main topic. Prefix. Okay, write down on the prefix. The magnitudes of physical quantities. The magnitudes of physical quantities can be varied from extremely small scale, extremely small scale to a extremely large scale. In such cases, we cannot use the SI scale, to measure those values, Okay. Example number 1. Example number 1. Measuring atomic radius using a meter ruler. Measuring the atomic radius using a meter ruler. Measuring the atomic radius using a meter ruler. Second example. Measuring the distance from the Earth to the Jupiter. Measuring the distance from the Earth to the Jupiter using a meter ruler. Under this in a new paragraph, write it down. So we have to convert the SI unit into a larger scale, or a smaller scale to measure these kind of values, to measure these kind of values. Okay. Then there's this unit system. If we want to convert this one into a large scale, we have to multiply that by suitable number. We have to multiply. Example 1 meter into 10 to the power 3 is 1 kilometer. 1 meter into 10 to the power 3 is equal 1 kilometer. If we want to convert SI unit into a small scale, we have to divide. As example, 1 meter is divided by 10 to the power 3. We will find 1 millimeter. 1 millimeter. Okay. Okay. Right under the paragraph. Don't draw this. Okay. I will give the time. Okay. If we want to convert SI unit, if we want to convert the SI unit into a larger or small scales, we have to multiply or divide the SI scale by a suitable number. Write in a new paragraph. To represent that number, to represent that number. It is given a special name. It is given a special name and symbol. A special name and a symbol. That name is called as a prefix. That name is called as a prefix. Okay, look at this. Look at this now. Here now SI units. If we want to convert SI units into a larger scale, we have to multiply them, and the numbers are the multiplication numbers are called as multiples. As an example, if we multiply 1 meter by 10 to the power 3, we will have 1 kilometer scale. 1 kilometer scale. Then, if we want to convert SI unit into a small scale, we have to divide them. We have to divide them. The number that is used to divide the SI scale is called as submultiples. So, as example, 1 meter scale, if the 1 meter scale is divided by 10 to the power 3, divided by 10 to the power 3 means multiply by 10 to the power minus 3, okay? Then we'll find millimeter scale, okay? So, kilometer scale, millimeter scale. Milli, kilo, those are the words that is used to represent the multiplication number. Those words are called as prefix. Those words are called as prefix. Okay. Okay. Write this one. Write this one. How to divide, how to multiply. Okay. After writing this one, write under this. Prefixes can be divided. Prefixes can be divided into two categories. After that, you can write this one. Prefixes can be divided into two categories. Okay? After that one, those are two categories: multiples and submultiples. Okay, multiples and submultiples. Those are the two categories of prefixes. Okay, Buddha. Okay. Now we are going to finish the class. Up to now, we have discussed up to now what are the what is the physical system. Then we have discussed about physical quantities. What are the physical quantities and what are the categories of physical quantities? We have divided the physical quantities into three main categories. After that, we have categorized the physical quantities again according to their properties, vectors and scalars. But we have considered the direction, magnitude, and the unit. Those are the properties we have considered during this classification. Then we start to discuss about units. Then we have discussed what are the ancient unit systems. Then about SI unit system. If you consider about SI unit system, we have discussed about three main categories of SI unit system. Those are basic units, that's been fundamental SI units that are used to measure fundamental physical quantities. Then we have discussed about supplementary SI units that are used to measure supplementary physical quantities. Then we have discussed about derived physical quantities. When we were discussing about derived physical quantities, we have discussed how to derive a SI unit of a derived physical quantity. Okay. Then we have learned about two type of derived physical quantities. Some derived physical quantities have special names. So we have categorized derived physical quantities into two categories. What are those? Derived physical quantities without a special name and derived physical quantities with a special name. Normally, the derived physical quantities with special names are the names of scientists. So the symbol of the derived physical quantities with the special name should be start with a capital letter. Then after that, we have discussed about prefixes. What are prefix? sorry, why we need a prefix? We have to convert the signs into a large scale or a small scale. Then we have to use a suitable number to multiply or division, multiplication or division. So that number should be represented as a standard symbol. Then anyone can understand what is the multiplication number of this scale. Okay, so to represent that number in standard way, we have to use a symbol and a symbolic name. That is called as a prefix. Okay, those are the things that we have discussed during this class. Okay, if you have any question, please let me know. Please ask in our discussion group. Okay. Okay, Buddha. So now it's time to say goodbye. And have a nice day. Okay. Thank you.